Okay, so we've got a CRT 2000H. In fact, we've got two from this customer for optimisation. I think they're in some kind of courier business. They want to use CTCSS, but unfortunately, they set them how they wanted them. I think there's some programming method with DCS tones, digital code squelch. But we can't read digital code squelch, and they sent the radios and programmed them before telling me. So the snag is that I don't think there's anything we can do with DCS, because our 1982 test gear doesn't read DCS because they hadn't invented it. We had Marconi 2955s, got rid of the Marconi 2955s and bought the earlier 2951s because they're quicker for me to use. And at the end of our day, our business customers use CTCSS and the CB customers don't use CTCSS at all. When we originally did the ordinary CRT 2000, I found it so fiddly that I found the thing hateful. Worked fair, it works all right, don't get me wrong, but once you start with colour screens, you think they've spent all the money on messing with colour screens instead of real performance. And then I vowed in my head that we would never take any in for repair. And then, blow me, 3 months down the line, we got one in from a local chap, and he'd bought it second hand. The damn thing had blown up. I don't know whether in his custody or it just never worked. And when I opened it up, it had been messed with, or shall we say modified. And I had to import the regulator IC. I think it was from Singapore. And Mr. Chippy spent a lot of time fitting it. We charged him just some token fee. So I think we'll look at it as a normal set. I'm doing this today, starting at 4 o'clock in the afternoon. We've just been starting on a ham radio set, which we don't repair ham radio sets, but again, it's one we've ended up kind of somebody local, trying to help out, la-di-da-di-da. We do only do FM, I'll rephrase that, we'll only be prepared to look at FM only sets anyway, because we have no SSB test equipment. And I would want to test things and be able to align anything that we have in for service. So, I'm not doing any organ work today because it's bank holiday, and that's a public holiday to anybody out of the UK. What's strange about bank holidays is the banks continue to charge you interest even though they're having a holiday, whereas if I don't go to work, I don't get any money. So I'm not quite sure how that works. A different set of rules for them. So we've got 13.8 volts on the power supply and the thing's lit up like a Christmas tree. So I'll plug it into the test gear, and he's sent these in for optimisation, and then he wants to do some extensive tests, which we did want to do some CTCSS tests, and that's why I've okayed it. Okay, so let's go into transmit and see what happens. 2.32 amps. Good grief. So it's come on 26965, which is CPT channel 1. So for a start, we're going to find how we get out of that. So it's what's modulation? Well, It's FM, so what's it got? I don't know. It's on AM, is it? Oh, band UK. Is that it? There we go. Hey, we've changed channel now. I can't believe this is drawing 2.37 amps for what output? I'll tell you what, I'll put the picture in picture on. For 3 watts. That's got to be the most power-hungry radio I've ever come across. I've got a radiogram coming in for service tomorrow. We don't encourage these things. The whole reason we do these videos is to get people to sort their own out. We most definitely don't want to be generating business, because we've got on enough business with the church pipe organ restoration, which is our main thing. But all that said, we've got a shorter screw there on that one. So I think we'll be doing some radiogram service videos just to annoy you all. Tell you what I do like, this, when it's on, there's a bit of light comes from its display, and it helps light up the radio. How many volts are these? Oh, 13.8. Right, we'll pause the video. Right, so if we go into, it has 7 presets, not all are used unless it's in some kind of weird Russian mode, and we're not in weird Russia, so where's my little tool gone? There we are. This one going to fit. So if we start off with W2, which is power, trouble is, if I turn this up, will my power supply be able to deliver? Well, it will do 4 watts. It'll actually do 5.1. So there we are, spot on the 4. It's now drawing 2.8 amps, which is beyond the capability of the power supply. So that's covered that. So that's W2 was the power. Because I can access AM easily, we will test that. So go to AM. And we'll select that from the front. Is where we start with the FAF. Band U, band AM. Doesn't really matter what channel I do this. Oh. that knob's now become this knob's now turning. Do I have to do something? Do I have to press something? Do I have to press that again? How do we change channel then now? Do you have to hold on to this? No. You have to press transmit. It looks like you have to press transmit to verify it. So we're still doing 4 watts and we're now on 27205. Don't recall you can trim the frequency on these. Let's just show you we're on frequency. 27. Oh, we've changed channel. 27205. Slightly low. So go back to there. We'll check the AM mod. I'll just have to tune my machine because we were last on 400 and something megs for 77 AM. Wallow. Well, it's 1, 2. It's going full scale deflection. I'm not going to alter that. I mean that would say it's in excess of 90%, so that's fair enough. But if we'd have needed to adjust AM mod, we would have adjusted what? W6. And W6, these aren't in order. W6, they are clearly labelled. W6 is that one, the second from the left. Because so far we've adjusted W2, which is the middle one of the 5 there. There's 2 down there as well. You've got, I'll just point out the order, but they're clearly labelled. W3, W1, W2, W2, W6, W4, and then to my left we've got W5 and to my right W7. So that's done that. So we're fine, we can go back to FM. So UK. So are we really in UK? Yes, we are, and it's spot on frequency on that. So that automatically puts us back onto FM. So we'll look at the deviation. While of course we've got to tune the thing. 1 2 1 2 wallow. 1 2 1 2 1 2 1 2 1 2 1 2 wallow. Wallow. It's 1.7. It's pretty dreary. So of course this is why these come in for optimisation. So deviation is W5. So W5 is this one down here to the left. So we'll get our little oscillator out. See how that is. 1 1 2. That's far too high. 1 wallow. 1 2 1 2 wallow wallow. 1, 2. Wallow. Testing 1, 2. Testing 1, 2. Wallow. Testing. Wallow. 1, 2. Wallow. It's weird, this. Really, really weird. That's not our monitor receiver. 1, 2, 1, 2. Testing 1, 2. 1, 2. It starts off higher than the deviation I want. Look, as I attack, look at this, it goes over. Wallow. And then it settles about where we want it to be. Wallow. 1, 2. Wallow. 1, 2. 1, 2. 1, 2. Wallow. 1, 2. It's a weird radio. I think that's about where we want it. But our next thing is CTCSS. Now, he's programmed CTCSS on some particular channels, and it's not that one. So let's just look at his notes. But, oh, except he hasn't. He's programmed DCS, which we can't read. So he's put it on channel 32, he says. So put the radio on channel 32, except the up and down confuse me then. I can't read CTCSS on that. Don't know about you. Wallow. Let's just retune the machine. 1, 2, 1, 2, 1, 2, wallow. Yeah, it is there. I had to retune the thing. So if I just go up another channel, he's got it on there as well. So that's channel 33. And if I go to channel 4, he hasn't got it on there. Yep, that's right. So this needs to be, in my experience, 0.37. Theoretically, CTCSS is... But I've got no training on DCS, so I can't speak for that. And I can't read it anyway. But... CTCSS should be 10% of the maximum deviation. So, if the radio's absolute maximum deviation is 2.5 kilohertz, it's supposed to be 0.25. But in reality, after years of experience doing this in business radio, I found 0.37 is the best. So, where's he got it on DCS? Oh, I've got to go back down to the channel he's got it on. So it's about 0.38, which is spot on. So the preset for the deviation is W7. So W7 is the one to the right. So the normal deviation is to the left, and the CTCSS and DCS deviation is to the right. So I'm going to have to find... I think he says there's an instruction book in with the other set. Trust me to pick out the... Oh, no, it's come, hasn't it? It's with this one. I was going to say, trust me to pick out the wrong set. So I'll just have a quick look. How do we change to the CTCSS? One of the things I recommend when using CTCSS is to use 118.8 as a good starting point. Some radios, when they receive a CTCSS tone, they start at 67. If it isn't 67, the computer inside tries 69.3, and if it's not 69.3, it tries 71.9. If it's not 71.9, it tries 74.4, and so on until we get to 250.3 is actually top of the shop for UK CTCSS, and you would never ever use 100 in the UK because the mains is 50 Hertz, so twice 100 is problematic. I can promise you it's problematic, so it's not one of the ones you'd use in the UK. It's not illegal, but it's not on the normal list. So if you have the... Yeah, I've just told you a whole load of bunkum. It starts at the top. So if it's 250.3, it moves down to 241, and so it goes on. By the time we get to 118.8, we're kind of 2/3 the way down. So these usually take about half a second to decode. If you go down to 67, you can end up with it being 1.5 seconds to decode. So people are used to things working instantly, and we've got a lot of modern radios that when you press transmit, they take 1.5 to 2 seconds to go into transmit because the CPU controlled, and then to go back to receive, if it takes 1.5 to 2 seconds because it's looking for the CTCSS, it's going to annoy people dramatically. Of course, they can go out and buy a Rotel 230 or something from the 1980s, which will be instant, but the latest set, the current sets, are getting slower and slower, the more CPU stuff they're packing into them. So, I'm going to suggest we put in 118.8. Then if he ever says to me, what did he put in, at least I'll remember, because that's what we would normally do. So those higher ones are normally faster to decode. Now, of course, it depends how the radio works, but that's my recommendation. So how do we put in a CTCSS code? And I'm going to have to look at what he said. Now it seems to be, it says optional. So is that subboard which is in the top? I would bet it is, because it's clearly showing something on my machine. Yes, an optional CTCSS board. So that must be what's fitted. Right, I'll pause the video. I'll just look at... what am I looking at? I've forgotten already. Oh, what his notes were is to what channel to put CTCSS on when I said we can't read DCS. Okay, I've looked at his notes. This is going to be fun. Function. So short press the function key. Repeatedly short press the programmable key that's associated with the tone squelch function. So which one's that then? Right, I seem to have got to grips with this. It's a bit ambiguous, like a lot of these menu things are. So why are we on channel 9? So we've now put CTCSS on channel 32. So I'll tell you what we'll do. We'll leave that at... Yeah, we'll leave that on channel 32, and his channel 33 will leave as he's programmed. That's a really good way to do it, I think. I think what we'll do, we'll modify channel 31 to put CTCSS in. So, long press of function, and then we can go down to the channel menu, press enter, go down to the, whoops, you've got to be really quick with this, to press CTCSS, set it, turn that to 118.8, which is what we're going to do, enter, long press, then we want to go down to the next one, which is the transmit. That's receive. This is transmit. So now it's gone green. Turn it to CTCSS. Press enter, and turn that until we get to 118.8. Long press, enter, and then I think that's the back button. Yeah, exit. So now we've put that in on channel 31, 1, but we haven't implemented it. So function, nope, out of it, short press a function twice, tone squelch, and there we have tone squelch on. So we now have channel 31 with tone squelch as well. So hopefully, exit. So now we'll look at the test set and we'll see what it says. So in transmit, oh, it's gone over the power. This is it, you see, they cool down. Which was it? It was 2. So, we're now looking at the CTCSS. So I want to see what the deviation level is of the CTCSS. Now we chase it on the tone squelch, which you've got in. They're both generally called tone squelch. On the digital code squelch, which you'd already put in. So we'll now see what the deviation is for CTCSS. Hopefully it's the same. We need that to be higher. I need it to be 0.37 and it's about 0.25. Okay, so that's now set up. Now the next thing we're going to look at is I should now have 118.8 on my frequency readout. I have 119. We can't resolve the other digit. It only does this 3-digit. Wallow. So if I put the tone generator on, you'll see it's about what, 990 or something, 930. We'll have to modify that. So that's all set up. So we need to do the other one the same, and then we can do an on-the-air test, and hopefully that will work super duper. Now, to test receive, I'll now need to put, so we're on channel 31, to test receive, I'll now need to put this frequency into my signal generator. I think I'm going to do... Oh no, we haven't got that plugged in. So it's 2790125. So we'll put that into the signal generator. So there we have 2790125 on the signal generator. So now we shouldn't hear anything. So I'll show you the attenuator. So we're at 0.3 of a microvolt. It's on. So if you look, let's put S9 on the signal generator. So that is S9. These read a bit low, as you can see. That's what they think is S9, but it's not adjustable. But we can't hear anything, can we? Because the CTCS is holding it. So what I now have to do is, on my test set, I have to, instead of putting the 1 kilohertz tone in we normally have, I need to change that to 118.8. So let's see what we've got. So at the moment, make sure you can see that display. We've got 1 kilohertz in, that's the normal tone. So I need to change that to 118.8. And when that hits 118.8, we'll hear the radio open up, hopefully. There you go. Now, there's no tone now because it can either do CTCSS or it can do tone lock. And that has opened up. And all you're hearing there is the 118.8 generated by the test set. Now, if I suddenly change this, I'm going to go to 1 kilohertz. So that's 1 kilohertz tone. And it's shut down. Switched back to the CTCSS encode. And it's opened up. Switch it back to 1K. And it's shut down. So it's working absolutely perfectly, which is great. So out of interest, we'll see what the receive's working like. I'll leave it on that channel, that's fine. So, no, we won't leave it on that channel because we've got CTCSS on it. We'll change it to channel 30. No, stuff that we'll put it on channel 20 like we do normally. So I'll put 2779125 back in the signal generator. And we'll see what now we've got on the cyanide meter. I'll plug that in. Volume, turn, need to override the squelch. How do we do that? Squelch, off. So we're getting 0.35 microvolts for 12 decibel cyanide. So that's absolutely fine. And there's no adjustments for the receive. You get what you're given. That's how it is. So that is set up a treat. It's doing the full 4 watts. We'll go back to that. Which is just slightly over. And we'll put the 2 short screws in the left. And the 2 long ones in the right, because that's how they came out. And these are Torx T9. I'm sure once these are set up, they're probably going to be stuck on just one channel most of the time. And that I've put CTCSS on channel 31 and 32 and left channel 33 as they wanted with the original DCS. So when you find his letter, it's gone on the floor. I'll just make a note that just cover his email address so it doesn't get bombarded with sexy offers from some woman at the other end of the world. So we've put 118.8 CTCSS on 31, 118.8 CTCSS on 32, and as customer programmed on 33. So just so we know. Right, I will now do the same to the other set, and then I mean, these do work okay, but they, to my mind, are a faff to work. So we'll conclude with the second radio now done, and when I put it on channel 31 it says CT in its display. Put it on channel 32 it says CT in the display. When I put it on 33 it says DT in the display for the digital code squelch, and then all the other channels are as normal. In fact, there's a squelch popping through. Now if we turn the squelch down, it's a quick demonstration there, squelch down so as it's hissing, and then go into channel 31, 2 and 3, we can no longer hear the background noise because of the CTCSS, or the digital code squelch. But I'm just going to put the squelch on, otherwise you get an annoying tail. So we'll put that back to 37. Sorry, back to squelch to level 7. So that's the conclusion. So I find these a right faff as a mobile set to use in the car, but they want this particular feature, and at the end of the day, it's their choice of radio. So they're both doing 4 watts, they've both got good sensitivity, and let's see how they work on the on-the-air test with CTCSS. I'm going to probably do this in 3 ways. We've already done an on-the-air test for this set, so we'll probably go out with, I'll probably get Mr. Chippy to go out with CTCSS on and come back with digital code squelch on. I've got no experience of digital code squelch whatsoever, never experienced it, so we'll just we'll see how it works. Now coming back, he's got, although the error's in the middle of the roof of the car, for some reason it seems to work better. So don't get misled into thinking it works better, but I just want to experience it. We'll see what he says. He might want to go out, come back and go back out again, just so the tests are fair. I don't think we need to test the radios without the CTCSS because we've already covered this model previously. So thank you for watching. That's putting CTCSS and just tuning up those CRT 2000s.